Today I want to discuss about a problem that appeared in CMI Entrance Exam 2015. It's a calculus problem mainly involving a bit of integration and fundamental theorem of calculus. This will give you a general idea to how to solve this type of questions, and at the end of the video I'll give you a similar type of problem for you to try out. You can try out on your own, and if you find out the solution you can type your solution in the comment box.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So let's begin. We are given f from R to R is a twice differentiable function such that f dash x minus f dash y is less than or equal to 3 times mod of x minus y for all real numbers xy. I have to prove that for all xy, mod of fx minus fy minus f dash y times x minus y less than or equal to 1.5 times x minus y whole square. And I have to find the maximum and minimum possible values of f double dash x under the given conditions. So let's begin. One immediate thing is to observe that if we interchange x with y, the expression on RHS doesn't change. So interchanging x and y gives me f dash y minus f dash x. This is less than or equal to 3 times mod of y minus y, and that is same as 3 times mod of x minus y. So this non-negative quantity 3 times mod of x minus y, this is bigger than or equal to f dash x minus f dash y and negative of that also. So from that we get that mod of f dash x minus f dash y also less than or equal to 3 times mod of x minus y. For simplicity of notation, I assume that h equal to x minus y. So in this case we have mod of f dash of y plus h minus f dash y less than or equal to 3 times mod h. I have to keep the f dash y here because what I have to prove there is f dash y, so I need to involve that in some way. So I have to fix y and integrate over some x or h, whatever. So that's important. Now assume without loss of generality that h is greater than 0. So without loss of generality, h greater than or equal to 0, assume that. Like x is greater than or equal to y. Now if x is less than y, we will deal with that case later. But for the first, let's try to prove out the part A for x greater than or equal to y. Let's try this one out first. H is greater than or equal to 0. So for h greater than or equal to 0, we have this thing true and the RHS becomes 3 times h. Now pick any Now this holds for any h, like fixing y, this holds for any h greater than 0. Like any h greater than 0. If I fix y and vary over x. So I'm fixing my h and I pick any t belongs to this interval. So now I have mod of f dash of y plus t minus f dash y less than or equal to 3 times t for all t belongs to 0h. So this was for all t belongs to 0h, so I can integrate it over that interval. So integral from 0 to h mod of f dash of y plus t minus f dash of y dt less than or equal to 3 integration 0 to h t dt, and that is 3 by 2 times h square. Now one thing that we should all know that for any continuous function, integration from a to b fx dx, this is less than or equal to a to b integral from mod of fx dx. So modulus of integral is less than or equal to integral of modulus of a function. This is some sort of triangle inequality, and this is really intuitional. You can try that If you don't know, you can prove it on your own, and this is really intuitional in the sense that my f can be, if I integrate over, say this is my a and b interval, if I integrate over a lot of places, like in this interval, there are places where the function can be negative. So my total integral is the sum of all areas. Now there are also positive areas and negative areas also, but the negative areas make my total sum smaller, because positive plus negative make the total quantity to be small. But now when I take mod of f, so what does the modulus does to a function? It reflects all the part that are below the x-axis to above the x-axis. So if I take mod f, it just reflects over this thing. So now in this case, what do we have? The function looks like somehow this thing. That part that were already above the x-axis, those area already remain. The positive part already remain, but for the negative part, that becomes positive now. So whatever area we had, we have at least that much, but we get some more area, and that is positive. So this quantity is bigger. Like, it is intuition. You can prove it on your own. So using this, what can we say about integral from 0 to h f dash y plus t minus f dash of y dt less than equal to integral of modulus. And this is less than equal to 3 by 2 times h square. We know that. Now let's try to evaluate this expression first. What is this integral? This is 0 to h integral f dash of y plus t dt. We can evaluate it by fundamental of theorem of calculus, and this is f dash y times integral 0 to h just dt. Because I have fixed y and varied over x, so that h is varied, so f dash y doesn't depend on h, so it behaves like constant in the second case. This quantity is just my f of y plus h minus f of y plus 0. So f of y plus h minus f of y. And this is h times f dash y. H times f dash y. So from that we get mod of f of y plus h minus fy minus h times f dash y less than equal to 3 by 2 times h square. So now I can put that value of h equal to x minus y. So this directly gives me f of y plus h, that is fx minus fy minus f dash y times x minus y less than equal to 3 by 2 times x minus y whole square. So the part A is proved when my x is greater than or equal to 1. Now we need to modify our proof for if my x is less than, we need to modify the proof up. Now if x less than y, that would mean my h is less than 0. In that case, I'll integrate over this interval. In this case, we integrated over 0 to h. Now I'll integrate over h to 0. We just need to change our integration bounds, and the rest all things are almost similar. You can try that one. I leave it for you to prove that part. So for x less than and x greater than equal, for all cases we have proved the part A. So part A is done. Now we need to do part B. We need to observe we have mod of f dash of y plus h minus f dash y. This is less than equal to 3 times mod h. This is for all h. So that gives me mod of f dash of y plus h minus f dash y by h. This is less than equal to 3. For all h not equal to 0, I take not non-zero. So now I can just take the limit. Limit h tends to 0. And as my modulus function is continuous, I can put the limit inside. Remember that if you want to find limit some x tends to a, f of something, and you want to put the limit inside, so your function should be continuous at that point. And here my function is the modulus function, it is continuous everywhere, so I don't need to worry about here. So mod of limit h tends to 0 and this quantity, and this is, we know that this limit is by definition f double dash y. So mod of f double dash y less than or equal to 3. So f double dash y is bounded between -3 and +3. Now I need to check whether this bounds are attained or not. Can f double dash y be plus minus 3 given the conditions? Let's see, like when my f double dash is +3. If f double dash looks like +3, then my f dash should look like 3 times some linear function, 3 times some t. And in that case, my f should look like, by indefinite integration, if it is 3 by 2 times some t squared type of thing. And you can easily check out that f of y equal to plus minus 3 by 2 times y squared. These two functions satisfies the given conditions. And it has f double dash y to be plus minus 3. Like the for plus 3 by 2 x squared is plus 3 and for minus 3 by 2 x squared is minus 3. So you know that this bound must be true and the bounds are also attained. So these are the all possible maximum and minimum values of f double dash y. So max is plus 3 and minimum is minus 3. And this is the answer. We are done. Now, as promised, I'll give you a similar type of problem. So let's do that. We are given f from, okay, not given. Find all functions that map R to positive real numbers such that f is twice differentiable f double dash is continuous everywhere and this is greater than or equal to 2 times f dash x whole square for all x in R. So you need to all continuously twice differentiable functions such that f double dash x into f dash x greater than or equal to 2 times f dash x whole square for all real numbers x and y. Try that on your own, and if you find out a solution, you can type your solution or the ideas in the comment box. And if you like this type of problems, you can keep yourself updated in this channel, like follow this channel. There are a lot of interesting videos. Thank you.
Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.